Hello, everyone. Good evening. I have a little bit of music in the background. Let me just turn it down. All right. So I'm going to finish up chapter 5. For chapter 5, there are there's actually 3 units I'm going to be doing today, but I did 2 the other day, and that one is a different recording. I am going to start with just the solving of some of these problems for 5.3. I am going to highly suggest to please watch the media for 5.3 to help you understand the problems I'm going to solve, okay? So let's get started. If you have any questions, please ask. Have your questions ready. Okay. So 5.3. This is going to be 5.3 through 5.5. Okay. So 5.3 is, I'm going to just condense it and give you how to solve these problems. You are going to be looking at rational equations. Now, we had already seen, I had already explained in 5.1 and 5.2, the graphing. Now we're just going to be doing the solving. So you're going to be solving rational equations. That means you're going to be having fractions, like adding or subtracting. You're going to have, normally, these would be fractions that have numbers. However, you're dealing with polynomials, so you're going to be having different polynomials in different places. Okay, so in this case, what I want to introduce very briefly is the LCD. LCD is the least common denominator. My hand got a bit stuck there. Okay, the least common denominator is commonly confused as though the biggest or the smallest out of all, basically the smallest, but it's actually the reverse. The least common denominator is basically the same thing as the common multiple. Okay, so if you think of multiples of 3, you would start with 3, 6, 9, 12, and you add 3 every single time. Those are multiples. If I ask you, what is the least common multiple between 6 and 3, you would run a list for each of the multiples and see where they match. The very first number is called the least common multiple because it's the first one where they match. Will they match again? The answer is yes, but that's not the least one. There is no greater. Now, LCM, least common multiple, and least common denominator are basically and essentially the same thing. The M, standing for multiple, is basically the process of what you're doing to be able to put them in the denominator. Okay, so LCD is because you're using denominators. Sometimes they ask you to find the least common multiple of numbers that are not in the denominator. So that's why it's common multiple, not common denominator. Denominator is very specific to be in the denominator, but the process is the same. Okay, so the way I do it, okay, so these are my steps. You can look up other steps on Google, wherever, is basically you start off with number 1 by factoring. So you have to, again, and I mentioned this earlier in different chapters, is that you have to have your factoring down so well that you should be able to do them with your eyes closed. You are not going to be able to use the quadratic formula because quadratic formula is when solving, when you have a quadratic equation equal to 0. These are now denominators, okay? You're not into the solving yet. You have to factor first. So in order to factor, you have to know how to factor, of course. All right, so factoring all denoms. Okay, you're gonna go ahead and factor all the denominators, every single one. Okay, now to compose your LCD, okay, you're going to, well, I don't need that number 2. Start by copying the LCD of the first fraction. These are steps that you might want to write down on your note card. And the third one is add factors accordingly to account for every factor in the denominators. Okay, I'll explain how that goes. This is my method. I discovered that this method is my own method, and some students at the beginning were like, but if you follow the steps every single time, you will never get it wrong, ever, because there is a process, and it took me years to just come up with 3 simple steps to just make it as easy as possible, because for years I explained it and I explained it, and it just was not clicking and it would not click for my students until I figured, wait, if you do this, you get this all the time. And so this is my method. You do your own method, as long as it's correct. I don't care. All right, so what do we need? Let's start by giving you an example. Okay, let's start you off with 1. Here we have, they'll ask you to solve. Okay, so we have 1 minus 14 over x plus 48 over x squared equals 0. Okay, so the first thing you have to do is figure out the least common denominator. So when I say to compose the LCD, start by copying the LCD. It means here, what I always do is I always put LCD blank. And that's where I'm going to write my LCD. Once you find your LCD, then you multiply that by every single fraction, and every single fraction's denominator should disappear. If it doesn't disappear, one of 2 things happened. Either your LCD was incorrect because you didn't have enough factors, or second of all, you multiplied incorrectly. Your LCD might be correct, but you multiplied incorrectly. So one of those 2 things happened. Go back and check. All right. So how do we do this? If we have just a 1 here, I'm going to put this over 1 because all of these should have a denom. Okay, so I start by factoring all the denoms. In this case, you really can't factor an x, you can't factor an x squared, but for simplicity of this problem, I am going to rewrite this as x times x. I'll explain why as I'm doing this procedure. So you would factor all of them, and you want to see all the pieces in factored form. 1 is done, x is done, and I made this one visually x times x, and this one just 1. So this says, to start composing the LCD, start by copying the LCD of the first fraction. So this is the first fraction. I copy its denominator. Boom, done. All right, I'm done with step 2. The third one says, add the factors accordingly to account for every factor in the denoms. I'm going to put denoms plural because it's a whole bunch of denominators. Okay, so I'm going to use a pencil. Okay, the least common denominator of 1 is just 1. I mean, that's the number that's in the bottom. The next fraction has an x. I need to have every single part of each of the denoms in here at once, exactly once and only once. Do I see an x on this line? The answer is no. So I'm going to put it. Now, this one's accounted for. So I'm going to check off what's accounted for. That line has to have bits and pieces of everyone, if needed, to account for each fraction individually, not as a whole. So do not look, your eyes should not be looking at the entire thing. They should just be looking, let me cover this up. Let me use this. They should just be looking, like when I was doing that one, you should just be looking at that. That one's accounted for. The next one, you should just be looking at the denominator. Is that one accounted for? Yes, it is. And all the little factors in math, factors means multiply. So you would multiply them all. Okay, last one. That denominator needs 2 x's. You do not, I repeat one more time, you do not put two x's. No, no, no. That means you were not paying attention to what I just said. It means, where's my eraser? This is why I put it in pencil. You do not put whatever is in the denominator. No. You have to think, people. Think, think, think. The denominator requires two x's. But on my line, I already have one x. So all I need to do, because you need to match it up exactly. You don't want any more, you don't want any less. I need exactly, this fraction needs two x's. I already have one, so all I'm gonna do is add one more. And now these account for these two. Okay, last one. That needs the one, that one is accounted for, boom, I'm done. That is how you come up with the least common denominator. And it's a process that took me years, but this always works. If you just look at one fraction at a time and account for every single piece in the denom, you will always come out with the correct LCD. Now, when you multiply all of these, it's x squared. That is your least common denominator. Okay, so what you do now is you're going to multiply by each fraction. Okay, so I'm going to rewrite this at the bottom. 1 minus 14x plus 48 over x squared equals 0. And I'm going to take my LCD and multiply it every single fraction I see. Okay, all the denominators should disappear. Again, if they don't, you either multiplied incorrectly or do not have the correct LCD. So when I multiply these two, this one doesn't have a denominator. I just put a 1 to get this going, but this doesn't have a denominator, so it doesn't really matter. The whole point of doing this multiplication is so that all of these variables cancel. In this case, there's nothing to cancel anyway, so 1 times x squared is just x squared. Okay. The next one, x squared times 14x, 1 x goes away, which was my purpose, that x needed to go away. One of those x's canceled, so now I have minus 14x. Okay. The next part, I start over again. So some students do that, like I just keep erasing, or some students literally leave some gaps in here. They leave a space right here and a space right here, and they put x squared right next to each of the fractions, and then they visually cancel. That's fine. On the third one, the x squared goes away completely, dropping just a 48. And the last part is just still a 0. And now you can solve, and I will not finish this because this was not the point. The point of this is to get you to solve rational expressions. Sorry, I did not like that. Not expression, sorry, solve rational equations. Not to factor and not to solve it, okay? So you either then solve by factoring, which is the fastest way, most of these are factorable, or quadratic function, okay? You decide how to do it. Practice both ways if you'd like, but the whole point of this is to show you how to start solving the equations. These will end up as quadratics or linear, and after that, you should be able to solve. So for this, you can go back to other situations, because then I have to hit 5-4 and 5-5. And I just want you to get started with this, okay? All right, let's try another one. So let's make it a bit more difficult. Okay, what if we have 8 over x squared minus 2x minus 1 over x squared minus 4 equals 0. You're like, oh my gosh, that looks super hella complicated. Well, it's actually not too bad if you follow my steps. So first step, factor all the denoms. So I'm going to do it right below here. This is taking out an x minus 2. I'm going to briefly cross it up. This one is a difference of squares. So you have to know that it is a difference of squares. If you don't, go back to your factoring. Practice on factoring, okay? Pull up reviews, come into class and ask for help, book appointments with the tutors and the math center, whatever you need to do, okay? So I am going to now write down LCD, okay? So let's start this procedure again. This is covered. I'm looking at the very first fraction. My steps say copy and paste the denominators of the first fraction. So copy and paste. Boom, done. First step, easy. The first step is easy. The next one says, look at all the other fractions and add just enough to account for every single piece. Actually, I should have done that. X is accounted for, I see it here. X minus 2, I see it here. This X is not the same thing as this. I mean, it is, but it's not. This is its own group. That is its own group. So they do have to be separated, okay? Don't just think that this is enough because there's an X in here. No, X is its own group. So let's shift this over here, okay? And now this second fraction needs an X minus 2 group and an X plus 2 group. If I look on my line, I already have an X minus 2, so that checks off. All I need to add is or multiply by, is X plus 2. That is now my LCD. You don't need to multiply it out. The other one was funny to have it as X times X, but this one is, you wouldn't need to multiply it out. Actually, you don't want to multiply it out. Okay. So now I am going to rewrite this and I'm going to put them in factor form. So X minus 2 minus 1 over X minus 2, X plus 2 equals 0, okay? And now you take both sides of the equation and you multiply it by your LCD. I write them on both sides because students will forget the right side. A lot of the times it might not be 0, it might be a number. I accidentally put a plus first and then the minus, but it doesn't matter. As long as you have both in there, that's fine. All right, if I were to multiply this piece by this, my denominator should cancel. So this X is gonna cancel and this X minus 2 is gonna cancel, leaving me with 8 and X plus 2. That's why all the denominators have to be accounted for, because if there's one missing, that one will not cancel. And you'll have still denominators, which will not help you solve. All right, so that took care of that. Do you all see that? That canceled. I'm left with 8 and I just wrote it down. Now I'm gonna go through it. This is fine, this canceled, but I'm gonna erase this because I'm now gonna do that with this one. So I did that with this. Now it's gonna be that with that. I did that with that. Okay, so if I put it right next to it, because I don't have space, the X minus 2's will cancel, and the X plus 2's will cancel, leaving me with, dropping this negative, not forgetting about, with 1 times the X equals anything times 0 is 0. See how easy that was? You have a really complicated equation, and have it go to this is beautiful. Okay, this turns out to be a linear equation. This is not a quadratic, and all of the times will you have quadratic, so this is actually very easy to solve. You just have to put the like terms together and then solve it. Okay, so this one I helped you solve it just so that you could see that not all the time will you end up with a quadratic. It's very easy once you get this procedure down. Okay, so please practice that, look through the media. If you need more examples, I can definitely help you. We have one more to go of this type, and then I'll start 5 point. Also, I'll let you know the last thing you need to do here, but let's just go through the last one. 3x plus 1 minus 6 over x minus 1 equals 6x over 1 minus x squared. Okay, so we look at this first fraction. This is already a group. This doesn't need to be factored. There's nothing to factor here, nothing to factor. This one, this is a difference of squares. Anytime you see two things that are potentially being squared that might not look squared, like this one is a 4, but you can unsquare it. You can take the square root and that gives you x. This is x squared minus 2 squared. So potentially you can make that 4 into a smaller number squared, and you can have something squared minus something squared, okay? And so when that happens, it's a difference of squares. You need help with factoring? I'm making a point. This one, I could make 1 squared minus x squared. That's why it's a difference of squares. You can grab a 1, square it, cube it, take it to the 1000. It's still a 1, okay? Now, if I were to do the difference of squares, I would have 1 minus x and x. Oh, sorry. I don't have my wire. So 1 minus x and 1 plus x. Okay. Now, look at the denoms. You like this one? This one looks weird. These look okay? This looks weird. Okay. 1 plus x is the same thing as x plus 1. So I am going to rewrite it just so it matches, because if it doesn't visually exactly match, technically you can't put it on that line. However, 1 minus x is not the same thing as x minus 1. Okay, and you can test that by plugging in a number and just giving a value to the x. It is not the same thing. So the thing that happens here is what I'm going to do is take these two, pretending that they're two terms. I'm going to just swap the order. When I swap the order, you are not to swap their signs. Okay, so here we go. This, if I move these two, as I just swap them, okay, notice that the x is negative and the 1 is positive. So if I swap places, this is what it looks like. This still does not match that. But if I take out a negative, that then becomes x plus x minus 1, which matches this. Okay. So this is the same as that. And now the x's are in the same order. Why do we want to do this? And you want to do this. If they're not in the same order, if it's like 1 minus x and x minus 1, those are two different factors. And now you have on the line, you'd have to put more things on that line. And the more things you put on that line, it's not wrong. You'll just get a longer LCD. The longer your LCD is, the more stuff you have to multiply in the intermediate steps. Okay, and that might take you longer than someone who did this trick. Okay. The other thing is, if you leave this -1 in the denominator, that adds another number to the LCD. Remember that anything that's there in the LCD is going to be just adding to that line. So a trick that you can do is if you see a -1, and this is just with numbers, of course, and it will only be a negative. When you pull out a negative, this negative could basically move to the denominator. So I can write this down because now I have so much stuff here. This is 3 over x plus 1 minus 6 over x minus 1 equals -6x over this denom, x minus 1, x plus 1. See that? I moved this negative up. Now I don't have an extra thing in the denom. Now I have these match so that when I compose my LCD, I start with the first one, copy and paste. Boom, accounted for. Go to the next one. Do I have an x minus 1 group on my line? The answer is no. Boom, that's accounted for. Go to the last one. I need an x minus 1. Guess what? I already have it. Boom, done. X plus 1, boom, I already have it. If you had the 1 minus x, you'd have to put it down because it's different than x minus 1. So my LCD, now look at that. It just turned out to be this so easily, but with that negative on top. Don't forget about that one negative, okay? All right, let me use white sheet paper. copy this down again. 3x plus 1 minus 6x minus 1. I'm going to do what I said some students do. And some students leave a lot of gap and they put this LCD like this next to each fraction. And I still didn't leave enough space. I left it in the wrong place. Okay, so this is your equal sign. So that way you can clearly see, like I can cancel this now and be left with 3x minus 1. This cancels, 6x plus 1 equals, gone, negative 6. See that? And this will not be a quadratic because there's no x squares that are going to come out of this. So you distribute, you solve, get whatever. All right, now, the thing that you have to remember about 5.3 and when you're solving these rationals is that you have to just double check that whatever answers you get, and I wanted to say it at the very end of the last problem, whatever answers you get, do not create zeros in the denominator. Okay? No zeros in denominator. So let's suppose that you got an answer of x equals 1. If I were to put a 1 on some of the denominators, I would be creating zeros. So how do we test our answer? Go back to your LCD and make sure that this answer will not create a 0 in either of these. Either, I said, not both, but either. Once, like this one, that creates a 2, we're good. But if I plug in a 1 here, that creates a 0. That would be no good. Okay. But if my answer is like, let's say 4, that 4 does not give me a 0 in here, and that 4 does not give me a 0 in here, then that is my legitimate answer. So once you have your LCD, just make sure you go back and test your answer in that LCD. Making sure you don't get a 0 in the denominator. All right, that was a brief lesson on 5.3. Let's go over 5.4 and 5.5. This is a lot of algebra. All right, so 5.4. 5.4, we've got power and root functions. The form is the following. Okay. Why is it focusing? Put a stop on this focus button. All right. So f of x is x to the some power. That's a power function. You've seen these before. So these are pretty easy. You have quadratics, x to the second. You did the polynomials. You saw how they behaved. Hopefully you saw the behavior and all of that wonderful stuff. Now, you have, if the power, instead of a whole number, is a fraction where n is greater than 2, then the function is a root function. It means that anytime you have powers that are fractions, they become roots, which are basically radicals, and they are not necessarily square roots. So you will have something like this, x to the 1 over n, go to this, okay? It's useful using both. However, for doing it by hand and understanding what's going on, the radical one will be used more often. All right, now, that is just very specific to the 1 over n, but the more general form is a fraction that might have another number other than 1. I label the top P and I label the bottom R. Why? P stands for power, R is root. So power over root, the number on top will be the power on this base, whatever the base is. And the root is the root of the problems, and that will be here. That will be the radical. Okay, so if I ask you, you can just check these out. I'm going to briefly go over them. You'll understand them when you read them because I showed all the work. If you look at this one, for example, and I'm asked to evaluate 16 to the 3/4, 16 to the 3/4 is, that's the power, that's the root. So I take 16, I raise it to the third. So let me fix this. This will look like this: 16 to the third, fourth radical of that. Now, if you're doing this by hand, in class, I'll show you how to do it with the calculator. But if you're doing this by hand, you don't want to sit there and take 16 and cube it. That's a hella big number. Good luck to you if you can do that on the test. So you don't want to make that number large and then try to shrink it because that's going to take you longer. So what you can do is you can just change the order. You don't change the numbers, just the order. So instead of cubing and then taking the fourth root, you can actually shrink it. So whenever you take the radical of a number, you shrink the number. And then when you take the power, you enlarge it. So you can take the fourth radical of 16. It just means break down the 16 to little prime numbers. And for every 4, you take 1 copy out. That's what this little number tells you. For every 4 of the same type, you take a copy out. So there were 4 2s, 1 2 comes out, and then that answer gets cubed. And that gives me 8. Okay. Let's try to explain the other one. This was already set up in this form. Okay, so all we have to do is work with it. I will do the inside first. If it's an odd, you can just take that out as a negative. You don't pull out an I. This is not an I. Okay, so I'm going to break down the 64. Right now, I ignored the negative. I go ahead. I look for triplets. For every 3 of the same, you take 1 copy out. For every 3 of the same, you take 1 copy out. So, like I said, look, I just dropped the negative. I just ignored it. So basically, I take out 2 2s. I bring it down. Okay, I still just left the negative out there. I then raise it to the 4th, and that's 256. Okay. The next ones are basically the same thing. Power over root. So you can take this and say negative 125, the power, and then the root like that. This would be like that, right? The power over the root. However, taking negative 125 and squaring it is brutal. So I'd rather do the cube first and then square it, okay? Here's the same thing, power over root. The power is here. I don't want to take 81 and cube it. Hell no. So I'm going to cover up the power. I'm going to do the reduction here to a 9 and then cube that answer, and that's much easier. Okay, so here it says know how to do them by hand and check on your calculator. We can always go over that in class. Okay, so those are power functions that have fractions in the numerator. So this one we're almost done. This is very brief. I think I went over this the first part of the class. I went over these two. Square root functions, we did these when we were doing the shifting and the H and the K, how they move. Here's the domain, here's the range. We've done this. Where does it start? It starts here at 0 and it goes on to infinity. That's the domain. For the range, the lowest is 0. It goes up to infinity. Okay. For the cube root, again, you can put these on your calculator. You do not have to memorize these, but this goes left and right forever and up and down forever. Okay. These arrows are not horizontal. They go up like that. Okay, so it's obvious. And then x to the 2/3, again, you don't have to memorize this. You can just put it in the calculator. And then looking at the graph, it produces left, right forever. So negative, negative, positive, infinity. And then the range is from 0 all the way up to infinity. Okay. In order to find the domain for any of these, you just basically ask yourself, what is the radical? If the radical is an even, I hope you know what evens are, 2, 4, 6, 8, 10. You just keep adding by 2s. If this is an even, you grab this piece and you set it greater than or equal to 0. Why do we have it greater than or equal to 0? Because you can never have inside of even radicals a negative number. So it has to be greater than or equal to 0. And you go ahead and you do that. And that's because of the graph. Notice the graph. This is the graph of a square root, but it's an even. And look, it doesn't go down forever. It has a starting point, and then it goes on. But the cube root, notice that it goes on forever, left, right, up, down. That's why the cube ones, or the odd ones, the domains are reals, left and right. You don't have to put this and set it greater than or equal to 0. There's no need to, okay? Which is nice. This one is the same situation, okay? You grab this inside piece, you set it greater than or equal to 0, you solve it, and then you state what it is. You start from that point and you go on to infinity. All right, that ends 5.4, and now I will be doing 5.5. So these are just very brief introductions. Okay, this is what's going to be on your homework. Check the media just to reinforce, to have a couple of more examples. Again, I'm just doing brief intro to these. Okay, 5.5 are square roots. The only difficult part is the math, but your algebra has to be strong. If not, you'll definitely practice it here. Here are the steps. Again, I make my own steps, but this I think has helped in the past, and that's why I keep using them. So you can definitely write these down on your answer sheet, your note card. Okay. All right. Solving root functions. The first step is to isolate a radical on one side. Why do I say a radical? Because you might have a function that has more than one radical. Okay, you might have radical here, minus, plus another radical. So you have to just isolate one of them on one side. Which one you choose, it doesn't matter. The next one says, once you have isolated one radical on one side, then you raise each side to the reciprocal power. I'll explain what that is. You're then going to solve, and you'd be done if you only had one radical. If you had another radical, okay, so if there's another root or another radical, you go back to step 1, you'd isolate that radical again and repeat the process until you're done. Make sure that you check your answers. So it's very important to do this step, write it down in your notes. All right, let's begin with this one. So here's the original equation. I've got the radical of 11 minus x equals 1. I have to isolate the radical. So isolate the radical is the first step. I wrote all the steps out. And so that would mean for me to add an x. When I do that, I get something like this, right? So how do I get rid of the square root? This square root is technically, if you didn't know, and I'll say it now, so you need to write it down, please do so. So you should memorize this. Any square root meaning you don't see a number, but it's a hidden 2. Those are, whatever this is, those are powers of a half. Because remember, it's power over root. Power over root. Okay, power over root. Okay. Any cube roots are 1 over 3. Okay. So knowing this, if this square root means to the 1/2 power, and I asked you to, on step 2, I told you to raise each side to the reciprocal power. The reciprocal of 1 over 2 means 2 over 1. And that's why I'm raising both sides to the 2. So I'm explaining why you have to raise it to the second power. Because the power on this side, that radical, is technically 11 minus x to the 1/2. The reciprocal of 1/2 is a 2. That's why we raise it to the second power. So we take each side to the 2. Squares and square roots cancel, as you already know. This is a binomial squared. You are not allowed to just square the x and square the 1. That's illegal. You'll get this wrong. Okay. So FOIL, if it's a binomial, do the work. And because this is a quadratic, anytime you are dealing with quadratics, I will remind you many, many, many times, like I have in previous classes and many videos, when you have quadratic functions that need to be solved, you are not allowed to do whatever you want, okay? You need to set it equal to 0. That's what you need to do. Some students had or will have quadratic equations, or they'll have some quadratic and they'll have it equal to 4, and then just set it equal to 4. No, it needs to be set to 0. Clearly right here. Set to 0 if it's a quadratic. So I need to move everything, put it equal to 0. Reduce it as much as possible. Factor, again, this is where factoring comes in again. You don't want to waste your time and do a quadratic. You might be good at it, but get better at factoring. Factor and get your answers. Now, why did I cross this off? That's not a typo. Check your answers. You don't leave your answers like that. There are some answers that are not gonna work. So make sure, and you can't tell, okay? You take your number 2 in this case. So when x equals 2, plug it back into the original, not in this, because this will always be true. You take it back to the original and you do the math. You don't move things left, right. You don't add this x, no. From here, from the original, plugging it 2 everywhere x used to be. Notice that I did not move the 1. I did not move, I did not add a 2, nothing. Do not move anything, because then you're gonna make something that's false true. So I then reduced the left side as much as I could, and it turned out to be true. So that was good. Okay, the next one, I plugged in a -5. So I go ahead and I do the math. I don't move things left, right. I just keep reducing. And I ended up with 9 on one side and 1 on the other. That is not true. So that's why we cross this off. Therefore, the only solution is x equals 2. So you will have something like this on the homework on the exam, and they'll have answers like x equals 2. That'll be one of the answers. X equals 5. That'll be the second answer. X equals 2 and -5. That'll be the third answer. And the fourth one will be no solution. When would it be no solution? When you have your answers and you test both of them and neither of them work. That's when you would have no solution. And that could be possible. So on the exam, notice that you have sometimes a lot of multiple choice. You want to show your work, but that's how you would figure it out. Okay. Right. Last one's a bit brutal. It's still doable. All right. So this one, same thing. You isolate the radical. So you're like, I don't see a radical. Remember, fractions in the power are technically radicals. 1/2 means square roots. So whether you leave it as a 1/2 or you put it back in a radical, it doesn't matter. You have to know that fractions in the powers mean radicals. So I have to move the x again. I moved it over. Boom, subtracted it. This is a power of 1/2. So I raise it to the reciprocal power, which is 2. So I square both sides. Notice the difference in colors. That then cancels, dropping this alone and foiling that. Same exact steps. They're the same exact steps. I go ahead and I do the FOIL, and then I set it to 0 because I noticed it was a quadratic. I go ahead and I make it pretty, and then I factor. Factoring will be, when you get to the point, these quadratics will be very easy to factor, okay? Because you already did a lot of the work. You then get your answers and you check your solutions. So make sure that you check. I didn't cross anything off because they both work. Okay. All right, last easy one. Now don't let this confuse you. This is a cube root, okay? But it is not an x. You don't care. You're not solving for 5. You're solving for where x's are. So you look at this. That's a cube root. I can get rid of it by cubing both sides. So I don't care about this again. Raise to the 3rd power. So I'm going to raise it both to the 3rd power. This cancels and this cancels. This is a quadratic. You set it equal to 0. Use a quadratic since you cannot factor in this case. The reason I made it a bit more complicated, you end up with something like this. I will not have something like this on the exam because then you have to check these answers in there. That would be brutal, okay? But in this case, you would want to check graphically, okay? How would you check graphically? You already have your answer here. Okay, so yes, you have to still do the work by hand, quadratic equation. You set this equal to y1. on your calculator, you set this equal to y2, where they meet the x value, not the whole point, but only the x value. That was a question on one of the exams. The x values should be these two. If you only see one point where they meet, then one of these is wrong, either the -1 or the plus. If you see them meet at both points, then most likely both of them work. You just have to check that the answer is correct. Okay. So yeah, you would not want to check this by hand, but there's a way to do it, right? You would want to use and get used to doing these in the calculator. Okay. Last one. This one's the best. The least, we're almost done. Okay. This last one is number 4. Let's say you have 2 radicals. You're like, oh my God, 2 radicals. What do? You start by isolating one of the radicals. You don't want to leave the one that's a negative, okay? So I'm going to grab that, move it to the right. And my job is going to be trying to get rid of this radical here, the first one. So I add it, and this is what I get, okay? So I'm not focused on this one. I'm just focusing on this one. How do I get rid of this radical? I'm going to square. So square both sides. Bam. Now, when you do this, this is a binomial. It's got one term here added to another term. That's 2 terms. That qualifies as a binomial. So you're going to have to FOIL. Don't fret, I did all the work. So I wrote it twice. FOIL, since it's a binomial. So I did all the work. This. And then the middle 2 terms added to this. Okay. And that's how I got this part. Okay. Let me the middle. Okay. When I multiply the last one, these cancel because there's 2 of those. So the square and the square and the radicals cancel. So this is what I have left. Okay. So I got it to disappear on this side. I still have another radical left. That's okay. So I'm going to isolate the other radical. That's why I put it here in red, because all these pieces are going to move to the left. I'm going to isolate this again. Not again, that's a different piece. So I moved the x, the 1, and this one to the left, which gave me x plus 1. And that left with 2 square root of x plus 1. So to get rid of this square root again, you've got 2 choices. You can divide both sides by 2. Don't want to do that because it's going to create a fraction on the left side. So instead of doing that, I'm just going to go ahead and square. But when I square, make sure that this one you're going to have to FOIL. But you don't forget to square that guy. And when you square this one, it disappears. So watch what I'm going to get. FOIL this part. I get a 4 with the radical gone. Work with the left. Distribute the right. Quadratic. Set to 0. See? Same steps over and over. Math is just about practice. Set them equal to 0. Factor when possible. You get your answers. Check the solutions. They both work. Okay. How would you do this in the calculator? Practice doing this in the calculator. You would set y1 equal to the left side of the original equation. You would set y2 equal to 1. And where they meet should be at 2 places. And here are your x values. Try to do it on your own. All right, last one. This is only one more. And this is how to do these that were very similar to the quadratic ones that students have been getting incorrect on the exams. When I give you a function that has an equal sign and then I give you equalities, the whole point of me doing it this way is for you not to solve again B and C. That defeats the purpose. If I give you the same equation 3 times, why would you solve it 3 times? I don't understand. No. So first one, solve it the way you would solve it. Look at that. Boom, boom, boom. Square both sides, get an answer. Boom. X minus 1, done. So x minus 1 has a lot to do with these 2 answers, right? So now you would solve these graphically. which I have shown on several videos and during class. And what I wanted to show you is, now these are a bit complicated because they're radicals, but nevertheless, they are much easier than doing this by hand. You graph these, right? You put this on the graphing calculator. This first part is y1. You can see the colors, that's the purple. Y sub 2 is a 2. So that's a straight line. So the question is, where is the radical greater than 2? So where is this purple line above the red line? In the highlighted portion. Okay, in the highlighted portion. Notice how I wrote down who is the equation to what. So from where to where? From the -1 all the way to infinity. You always give your answers in interval notation. The reason why this is a -1 with the parentheses is because this is not equal sign. Okay. All right, and then I could definitely check. I did a check on this one. This check was for this, by the way. Okay, that check was for that. All right, the last one is I copied the same graph again. All right, but this time I want to know where the radical is less than 2. So the less than 2 is just this piece right here. So your job is to give me between what x values do we have that piece? X values, not y values. It is not 0. It is from this x value to the -1 that we had before. But how do you find that x value? Well, that's why you have graphing calculators. So you would find the 0, check where it crosses the x-axis, and that's why this is the answer. It touches -7/3, but the -1 still is a parenthesis, okay? And that is that. We have finished chapter 5 with everything we've done. If you have any questions, please don't hesitate to ask.